Hello. To start off, our objective is to use the fundamental counting principle to count the number of ways an event can happen. And secondly, we're going to use the concept of permutations to count the number of ways an event can happen. And what we're talking about when we say an event can happen, say like the number of ways, the first example, we're going to say the number of ways you can eat a sandwich. So let's say there's only two types of meat you can put on the sandwich, turkey and ham. But then let's say there are three different types of bread you can put on the sandwich: uh, white, wheat, and rye. Well, the fundamental counting principle basically says that if event one can happen in two ways and event two can happen in three ways, then the compound event can happen in two times three ways, or six ways. And that's illustrated in the first example on page 701 of your textbook. Um, but only if you sort of cover up the roast beef part. If you just sort of imagine, and maybe I can aid you in this. There, I blocked half the screen. So now, if you have two meats and three breads, then you get six sandwiches. And what if you increase the number of meats? Now you have three meats and three breads, then you have nine sandwiches. Four meats and three breads, now you have 12 sandwiches. So that's the fundamental counting principle. Now, we can use the fundamental counting principle to say how many license plates are possible. Let's say, apparently this used to be the case in New York, that license plates always had three numbers on the one side and three letters on the other. Well, first of all, you could say, well, how many number possibilities are there? Well, you have 10 possibilities for the first number, 10 possibilities for the second number, and 10 possibilities for the third number. 10 times 10 times 10 gives you 1,000 possibilities for right here. And that's intuitive, right? I mean, the top number is 999. So 1 through 990, 001 is the smallest, but 000 is the smallest. So really you've got 1,000 possibilities right there. And then how many possibilities here? Well, you have 26. 26 and 26. So 26 cubed times 1,000 is your answer, and it turns out to be over 17 million possibilities. So there's the fundamental counting principle. So that leads us to permutations. And permutations are useful for us for situations when you cannot repeat. So for example, let's say coming up with the AB, here we came up with a three-letter combination, and it turns out that the number of three-letter combinations that exist is 26 to the third power. So that's over 17,000 combinations. But what if I could only pick each letter once? So that's a slightly different problem. Like let's say I'm picking two letters. Let's just say I'm picking two letters. If I'm picking any two letters, but I can only pick each letter once, my first time I choose, I have 26 possibilities. But the second time I choose, I have 25 possibilities. And so the total number of two-letter combinations I can make is 26 times 25, which is less than 26 times 26. Now, this concept comes in handy. Let's say I'm putting a combination of students together. I'm saying, let's say I've got 5 students, and I want to know how many different ways they can stand in line. So what I can do is I can make a bunch of blanks. So if I have 5 students, the first blank, there's 5 possibilities, 5 possible students. But the same student can stand in 2 places, so then in the next gap, there's only 4 possibilities. The next gap, there's 3 possibilities. The next gap, there's 2 possibilities. And that, of course, that last student is just pretty much forced to stand in that last gap. So by the fundamental counting principle, the total number of combinations here is going to be 5 times 4 times 3 times 2 times 1, which equals 120. Now, because we use this multiplying of gradually smaller numbers as we do this, that becomes a thing we do often. And whenever we multiply with an integer times itself minus 1, times itself minus 1 again, times itself minus 1 again, all the way to 1, we call that factorial. We notate it with an exclamation point. So this down here is 5 factorial, and it equals 120. And within 5 factorial, you see, is 4 factorial. So 4 factorial is basically 5 factorial divided by 5, or 24. And you see 3 factorial is just this part right here. So 3 factorial is 6. And we're going to be using that a lot. But here, we're still in the fundamental counting principle. We're still figuring out how to order 5 students. And we just used logic to figure out, well, 5 possibilities times 4 possibilities times 3 times 2 times 1 gave us the answer. But that gives us a formula for how to find the number of ways to order n objects. And it typically is n factorial. N factorial ways. So if I ask you to find the way to order, let's say we have a race amongst all the students. But actually, we'll just stick to one group. So we have a race among 5 students. Well, then there's 120 different ways that those students can finish the race. But what if I don't care about, let's say I'm only giving medals to the top 3. So let's say we're not keeping track of the 4th place and 5th place. How many different possibilities are there for the top 3? Well, so now we're talking about the number of ways. Here we're talking about permutations of n objects. And we use 5 factorial. Permutations is a word meaning ordering. But sometimes we're going to ask about we're choosing amongst n objects, choosing five objects, but we only are taking 3 of the objects. So what we call that is we call that permutations, but what we say is we call it 5p3. And I'm reading from the book. It says the number of permutations of, in this case, the number of permutations of 3 objects taken from a group of 5 distinct objects is notated usually NPR. And the N goes in front and the R goes in the back. And it's calculated with n factorial divided by something. So let's look at this. I only care about the top 3. So I'm going to look at, there's 5 possibilities for 1st place, 4 possibilities for 2nd place, and 3 possibilities for 3rd place. And then, yeah, there's these possibilities for 4th place, but I'm not caring about that. I'm only looking at these 3 objects, so I get 5 times 4 times 3, and that's my answer, which is 20 times 3 is 60. So this, it turns out, equals 60 when I only care about 3 of the objects. And in general, NPR works that way. N factorial is the numerator. In our last case, 5 factorial is the numerator. But we divide out the part at the end. In this case, we divided out the part that we don't care about, the 2 and the 1. And in our formula, we're always going to divide out this minus this. So factorial. Let me give you another example. To finish the formula, so it ends up being n minus r factorial. Let's say I had a group of 6 students, and I only was interested in the top 2. How many possible top 2s are there? Well, so we're looking at the notation is 6p2. And I start with 6 factorial, right? But really, I only care about, the 1st place, there's 6 possibilities. The 2nd place, there's 5 possibilities. My answer is going to be 30, or 6 times 5. But the way it fits into the formula is it's really 6 factorial divided by 4 factorial. And so the 4 times 3 times 2 times 1 is canceled out, and I get 6 times 5, or 30. So that's how permutations work, and if you wanted to be following along page number on that last example, it was on page, I mean, not that example, but the definition of permutations is on page 703 in your textbook. Okay, there's one other thing that we should look at, and that's when sometimes we find permutations and some of the objects are repeated. So the example in your textbook is permutations with repetition on page 704. And so let's say we're trying to find out how many ways to rearrange the letters in the word cheese. And you're like, well, I know how to do this. Kind of. How many letters are there? Well, we got 1, 2, 3, 4, 5, 6. So if I rearrange them, I have 6 possibilities for the first blank, 5 possibilities for the second blank, 4 for the third, 3 for the fourth, 2 for the fifth, 1 for the sixth, 6 factorial, which is 720. However, I have 3 e's. So part of this 720 just has to do with scrambling the e's around. Now, how many different ways are there to scramble the e's around? Anytime I have 3 letters that I want to scramble around, any 3 letters, there are 6 ways to scramble them around. 3 factorial is 6. And there, I proved it. I couldn't help it. There's 6 ways to order 3 letters. But that means that of those 720 combinations, there should be like 6 times less, because there's 6 times more because of these 3 e's. So I'm going to take my 720 and I'm going to divide it by 3 factorial, or divide it by 6. And so I'm going to get the answer 120 ways to order the letters of the word cheese. 120 permutations. In general, my regular permutations or my regular ways of finding permutations is going to be, my n factorial. I'm going to divide in this case by whatever it is that's being repeated. So let's say another example is the word Mississippi, right? Well, here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I've got 11 factorial letters. So you think I might have 11 factorial possible ways to order it. However, there's 4 i's. So just messing with the 4 i's around is going to give me 24 permutations that are meaningless, because it doesn't matter what order the i's are in, they're all i's. Similarly, there's 4 s's, so that's 24 times more. So I'm going to multiply that in there also. I also have, it looks like 2 p's, so I'm going to put in 2 factorial. 2 factorial is just 2. So to find the total number of permutations, it's always, you multiply as factorial the quantity of times each thing that is repeated, and you multiply them all together. The formula on page 704 says n factorial over quantity 1 factorial times quantity 2 factorial times quantity 3 factorial. But in this example, you can see that each quantity is just the thing that gets repeated. So don't get this confused with the previous example where we divided by the number of, divided out the stuff we didn't care about. When we only were taking the top 2 students, or top 3 students, we divided out the bottom. That's another type of division we do when we compute factorials and find the number of ways something can happen. So different types of problems, you got to figure out which kind it is before you solve it. All right, thanks.